Good morning everybody, I am Sridharreddy. Today my topic is electronegativity. In order to know the definition of the electronegativity, first we will take one example. Let us take HCl, which is called as the hydrochloric acid. Hydrochloric acid is held by the covalent bond. What is the covalent bond? In HCl, hydrogen contributes one electron, chlorine contributes the one electron. Ultimately, the pair of electron shares equally by the two atoms. That's why the paired electron must be present in between the hydrogen and the chlorine. In between the hydrogen and the chlorine, because each is contributing the one electron. But actually, if you observe like this pair of electron nearer to the chlorine. It is not in the middle. It is nearer to the chlorine. Why? Chlorine attracts the pair of electron towards itself. Why? Chlorine will have the high electronegativity. So what is the definition of the electronegativity? The ability of attraction of paired electron towards itself is called the electronegativity. It attracts the pair of electron towards itself. This ability is called the electronegativity immediately. What are the units for the electronegativity? Electronegativity will not have any units. It is a unitless phenomena. Very, very important for the examination. Why it will not have any units? Because it is a relative theory. It is a relative theory immediately. How to calculate the electronegativity? Electronegativity can be calculated by using the two scales. One is called as the Mulliken scale and second one is called as the Pauling scale. Pauling scale and Mulliken scale. Why you are having the two scale? What is the need of the two scale? Mulliken scale is applicable for the atoms and Pauling scale is applicable for the molecules. This is the difference between the two scales. One will Mulliken scale, it is applicable for atoms, and the Pauling scale is applicable for the molecules. Now I am taking the Mulliken scale. According to the Mulliken scale, electronegativity is equal to average of the ionization potential and electron affinity. Average of the ionization potential and electron affinity is called as the electronegativity. But this ionization potential and electron affinity will have three units. Electron volts by atom, kilocalories per mole, kilojoules per mole. Whenever he gives in your examination units, then the value will be slightly changes. Now I am giving you. Ionization potential is given in the electron volts. Electron affinity also given in the electron volts. Then it must be divided with the 5.6. It is not divided with the 2. It must be divided with the 5.6. If ionization potential is given in the kilocalories per mole, and electron affinity also given in the kilocalories per mole, then it must be divided with the 129. If ionization potential is given in the kilojoules per mole and electron affinity also given in the kilojoules per mole, then it must be divided with the 540. Then only you will get the accurate value. You will get, generally we can say, according to the Mulliken scale, electronegativity is nothing but average of the ionization potential and electron affinity, but based on the units also slightly changes takes place, and it is applicable for only atoms only. So this is about the simple introduction of the electronegativity. Now I will take the Pauling scale, which is the very, very important. Pauling scale. Already I mentioned it is applicable for the molecules. It depends on one phenomena. That phenomenon is called the bond energy. Very, very important. It depends on the bond energy. It is applicable for the molecules. I am taking the equation. I am taking according to the Pauling, and given one equation, XA minus XB is equal to 0.208 into root delta, where delta is called as the bond energy, and the delta value will be the kilocalories per mole. Whenever he gives you delta value in the kilocalories per mole, then the Pauling scale will be the XA minus XB is equal to 0.208 into root delta, where delta is called as the bond energy, because this phenomena depends on the bond energy. Now second equation, XA minus XB is equal to 0.1017 into root delta, whenever the delta value is given in the kilojoules per mole. Kilocalories per mole, one equation, kilojoules per mole, one equation, depends on the bond energy. Here, what is the XA and what is the XB? Immediately we will get doubt. XA is called the electronegativity of A atom, and Xb is called as the electronegativity of the B atom. So AB molecule is taken, and among the two, Pauling has taken the 1 as a standard element, and the standard element according to the Pauling is hydrogen. He taken the electronegativity of hydrogen as a standard element. Standard electronegativity is taken 2.1, very important for your examination. He asks you in the Pauling scale which element is a standard element, what is the electronegativity of that element. So standard element among the two, A and B, two elements, is taken 1 as the standard element, and the standard element is taken is the hydrogen, whose electronegativity is 2.1. By taking this one, he calculated the remaining second element electronegativity, and he observed that fluorine, which will have the highest electronegative element, and here I am not mentioning any units, 4 only I am saying. Fluorine is the first highest ionization, highest electronegative element in your periodic table. If you take, that will be the fluorine you are having, and the chlorine and oxygen, which will have, both will have the 3.5, which are the second highest electronegative elements you are having. Then what is the importance of this electronegativity? Electronegativity gives you the two things. One, nature of the bonding, nature of the element. Nature of the bonding and nature of the element. What is the nature of the bonding? Look at here. The electronegative difference between the two atoms is greater than the 1.7. Electronegative difference between the two atoms is more than 1.7. Then there exists the ionic bond between the two atoms. What is the bond? The bond is called the ionic bond. How you can say? Electronegative difference must be more than 1.7. There exists the between the two atoms, what type of bond you will get, which is called the nature of the bonding. The bond is called the ionic bond. If the electronegative difference is less than 1.7, then we can say the bond takes place between the two atoms will be the covalent bond. HCl I was given. H plus Cl minus is there, but it is a covalent compound I mentioned. Why it is the covalent compound? The electronegative difference between the hydrogen and chlorine is less than 1.7. That's why there exists the covalent bond. If electronegativity is exactly 1.7, then what we can say? We can say 50% are the ionic character and 50% are the covalent character. So these 3 points are also important. Then what it gives you? It gives you the nature of the element. What is the meaning of the nature of the element? It says that which element is a metal and which element is a non-metal. Metals and non-metals can be classified, can be differentiated by using the electronegativity. Highest electronegative element, any element which will have high electronegativity, which are called the non-metals, and low electronegative elements are called the metals. So anybody asks you what is the metal and non-metal, we can frequently we use as metal, non-metal, metal, non-metal. What is the metal? Any element which will have the low electronegative elements, those are called as the metals. Highest electronegative elements are called as the non-metals. Now, how it varies in the group and the period? I am taking the group. In the last video, I was given atomic radius. Atomic radius in the group. How we have to move in the group? Top to bottom. As we move top to bottom, atomic radius increases. Atomic radius increases. What is atomic radius? The distance between the center of the nucleus to the valence electron increases. Whenever the distance increases, nucleus attraction over valence electron decreases because distance is high. That's why attraction of the nucleus over valence electron decreases. Attraction decreases, nothing but electronegativity decreases, because the ability of attraction is called as the electronegativity. Nucleus attraction is decreasing. Why it is decreasing? Because size is increasing. Where the size is increasing? In the group. Why it is increasing in the group? Yesterday I was given. So top to bottom as we move, atomic size increases, nucleus attraction decreases, nothing but electronegativity decreases. In the period. In the period, how we have to move? We have to move from the left to right. As we move left to right in a period, atomic radius decreases. Atomic radius decreases. Whenever atomic radius decreases, nucleus attraction over valence electron increases. Nucleus attraction increases, nothing but electronegativity also increases. So in the last video I was given, as the atomic radius increases, now I am giving you atomic radius increases, remaining 3 property will be decreases. 3 properties are ionization potential, electronegativity, electron affinity. In a period, atomic radius decreases. Atomic radius decreases, nothing but remaining 3 parameters will be increases, because atomic radius and remaining 3 parameters are inversely proportional to each other. Thank you.